Hello and welcome to another video. This time we're using AgonDev to create some transformations and buffered commands. We'll be looking at how we can scale and rotate a vector graphic by using buffered commands. What do we mean by buffers? Well, buffers are simply a bit of memory on the VDP that can store data. This could be anything from bitmaps, sounds, raw binary data, or in our example, sequences of plot commands. Buffered commands allow us to preload a sequence of commands onto the VDP for quick access at any time, avoiding the need to reload it each time we want to run that code. If we think about the processors involved, the VDP side run with the ESP chip is significantly faster than the EZ80. So any commands put onto the ESP will run much faster. In this example, we're going to use 3 buffers. One containing the original vector data, one containing information about the transformation, and a third where we'll put the vector data which would actually be plotted to the screen. A transformation matrix defines what changes we want to make to any particular bitmap or vector data. This could be a rotation, translation, a scale, or a skew or shear. A scale will make an object bigger or smaller. A rotation can turn an object anti-clockwise or clockwise to any angle. A translation will move an object either in the x or the y coordinates. A skew will take a certain angle and shift an object, whereas a shear will shift it by a number of pixels. Our alien ship example is made up of 14 separate plot commands. It starts by moving from the central point and then starts drawing a line to different points and moving to new locations where needed. And in our example, we'll be applying 2 different transformations to a matrix, a scale and a rotation. So if we take a look at some of the code, we can see that we've got some constants set up. The 3 we have here are the buffers that we're going to use. One for the original vector shape, one for the transformation we're going to make, and one for the final plot that's going to be put out onto the screen. We also have some other constants here that you'll see throughout the code. In order to plot, we need a number of parameters, and we've set up a struct here to contain those. There will be a vector, in this case it's either a line or a move to. There's also a pair of coordinates. In our main body of code, there are things you'll have seen before, so I won't go through everything. The key thing we're going to need to do before using transformations is set this test flag. This may become default in later versions of VDP. We're then going to set up our graphics, and this is a function that we're going to call to declare the actual shape of the alien that we're going to put onto the screen. Let's jump to see what we're doing there. So you see we use the actual struct that we defined earlier, and we're going to create 14 items in an array. Each item in the array contains the plot command, whether it's a move or line command, and then a pair of coordinates. So the first thing we do is that we make sure that the buffer for this shape is cleared. Then we write the data that we've just created in the array to that buffer. There are 14 items in the array of 6 bytes each, and we're going to start at the address where the array begins. And so back to our main code. We're going to set the colour to be a red colour and an angle of 0. This is what we will change as we go through a loop. And each time through this loop, we're going to clear the screen, print the title. We're then going to make sure that the transformation buffer is cleared each time, and the buffer which is going to contain the final plot commands. These will be populated with new data each time round the loop. So to create a transformation matrix for both a scale and an angle, we've got two functions we can call. The first one will create a scaled matrix. We choose the buffer and the x and the y scale. We then add to that matrix by including a rotation. So if we add another transformation to the same buffer, it will add that to the first one. And finally, we create a new buffer which has the original data but with the transformation applied. Now in this case, we're including a stride. That means that only the coordinate data will be transformed and not the actual plot commands themselves. So in this case, each chunk is 6 bytes long, and the offset of the coordinate data is 2 bytes into each chunk. So having cleared the screen, we'll plot first right in the middle. This is just an invisible dot as a starting point. And then we call the buffer, and it will execute all of the plot commands contained within that buffer. Now in this example, we're using a double buffered screen mode, so we call the VDP swap command. During this loop, we're also waiting to see if someone presses a key. The space bar will just pause things, and the escape key will escape out of the loop. And each time around the loop, we'll increase the angle and just check that we haven't gone past 360. Once we escape the loop, we then reset everything. And so running our code, we can see that our alien ship is rotating and has been scaled from its original size. Using the double buffer screen mode also keeps this flicker free. This technique can be used to add multiple objects at different sizes, scales, or different speeds of rotations. The same technique has been used here to create a multicoloured star backdrop, which moves. This game uses the same technique for the star backdrop as well as all the alien objects that are moving around the screen. Something for another video, but transformations can also be applied to bitmaps, whether translating, rotating, scaling, and shears. It can also be used to quickly flip an image from side to side, reflecting it in either axis.